Welcome to Dawg. I am Data and I'm your dog. In this video, we're going to talk about the foundations of probability. We're going to learn about what it is, why it's important, and many of its properties. Probability is extremely important. At its core, probability is trying to answer the age-old question of how likely is this? Depending on its context, this can be extremely easy to answer, or it can be one of the most complicated questions ever. However, there's no need to stress. Statisticians have a lot of tools to answer this question. It's important to learn how to walk before we can run when talking about probability and learn about the basics. When doing data analysis, you will find that probability is referred to as the p-value. The P stands for probability. When used this way, we are talking about the probability that something happens by pure chance, also known as random chance. If we are picking two different names out of a hat, we are assuming that those two names are the only names in the hat and that there isn't some sort of outside force that is giving one possibility an unfair advantage. Probability, when written in a research study, is almost always written as a decimal. In this example, the chances of picking one name would be 50%. If we were writing a study about this, we would write this as 0.5. Now there are some limits to probability. Probability can never be less than 0, and it can never be more than 1. If the two names out of the hat are Mike and Dave, what's the chance that I will pull out a John? It's 0. How can it be less than 0? 0 is already basically equivalent to an impossibility. If the only name in the hat was Mike and I was reaching for a Mike, what's the probability I would get a Mike? How could it be more than 1? Just like how 0 is considered an impossibility, 1 is considered a certainty. If the probability is 1, it has to happen. No ifs, ands, or buts. This means that if you are applying to be a statistician, in the interview never say you are going to give 110%, because they'll know that you just broke one of the first fundamental rules of probability. Laughter aside, let's go back to our original example. We have Mike and Dave in a hat, or we have their names at least. This is called the sample space. The sample space is a list of all possibilities. And according to probability, if we add up all the different possibilities, we will have to equal 1. Think about it. It is statistically certain that as long as we don't put the names back in, as we pick out each name out of the hat, we will eventually pick out every single name out of the hat. Next, we have the complement rule. Again, let's say I have two names in the hat, Mike and Dave. And let's say I'm looking for Mike. The complement rule asks what the probability is of not getting Mike's name. The way to achieve this is to calculate the possibility of getting Mike's name and then subtracting that number by 1. In this particular example, we simply subtract 0.5 from 1. Coincidentally, that is also 0.5. Statistics calls this the Q value. I like to remember this by noticing how, when lowercase, P and Q look exactly the same, except that it faces different directions. We know that P stands for probability, so Q is the complement. It's the opposite, in the sense that this does not happen. We barely scratch the surface of the properties of probability. However, we will come back to the other ones in due time. Congratulations! You've learned some of the most important rules about the properties of probability. You now know about the minimum, maximum values of probability and how it's expressed in studies. You know about the sample space, how likely something would happen, and how likely it would not happen. Stick around as we explore the wonders of data together here on Dawg. Don't forget to join our pack by pawing that like button, subscribing, leaving a comment, and sharing this video with the rest of your pups. So until next time, stay curious, stay analytical. Peace out, dogs.